computing. So, the agenda for today is I'll be explaining some basic knowledge regarding cloud computing. Later on, I'll explain you all how you can access the Google Cloud Console and how you can complete your labs. We'll go through the Skills Boost account overview so that you know what to do, and we'll also state some certain instructions that you all have to follow further for the process. So I hope this is clear. Now we'll be starting with the cloud basics. So let me share my screen. Now I won't be admitting anyone. If your friends who have not joined and want to join, tell them to join with their college accounts. So I won't need to do this. Is my screen visible?
Yes.
Yes.
So, all your doubts and questions I might take at the end or in between whenever I ask you all to. But before that, let me just start with everything without any interruption so that I can clear all the concepts first and then clear your doubts. Because most of your doubts might be cleared as and when I proceed with the presentation. So, give me a second. Yes, so let's start. The first question that I would like to ask is what exactly is cloud? So many of y'all might have some knowledge regarding cloud, and many are new to this field. So the first question which arises is what cloud is. So y'all can answer in the chat box if anyone knows, or else I'll proceed. Just few key points regarding cloud, what it is, and so on. At least say yes or no. Storage, okay. Any other keywords that you get to know? Storage at another location. Okay. So basically what cloud is, so cloud is a global network of servers. So basically they are the data centers and servers that are piled up at various locations, and you can access the resources through the internet. So this is what cloud is exactly. So there are some fundamental characteristics of cloud, and what they are is on-demand self-service. So what is on-demand self-service? Now, if you want to access anything in the cloud. So for example, I want a storage account, and the storage account should be either 5 GB, 12 GB, 18 GB, whatever. So for that, I need not contact someone to do that for me. So I can simply go to my cloud account and create my storage account, you providing all the basic name, ID, and all details for the account. And I get that created on my end. So that is what we call as on-demand self-service. So what you are doing is you are doing self-service. So you need not ask anyone to do so for you can do it on your own. The next is broad network access. So sitting in India, we can access resources which are available in US and various other geographical locations where the cloud data centers are located. So that is what it means about broad network access. The next is resource pooling. So what is resource pooling? So various resources are being shared among the customers. So for example, Microsoft or Google, both of them are providing their cloud resources to us who are the normal consumers. So this is what is called as resource pooling. That is, the provider shares resources to the consumers. The next one is rapid elasticity. What does rapid elasticity mean? So, as and when the needs increase, you can increase your amount of resources that you are using. For example, if for now I'm using a storage account of 5 GB, and further when I go and I need something around 15 or 16 GBs. So, what I need to do is it's very simple that we have to scale the resources. So scaling can be done in two ways. One is horizontal scaling, the other one is vertical scaling. So with the help of scaling, you can increase the amount of resources that you have as and when the need increases. And this scaling can also be done automatically, which is efficient for you. The next one is measured service. So what are the features of cloud is that whatever you use, you have to only pay for that. So only the resources that you are consuming and using, you have to pay for that resources only. I hope all the five fundamentals are clear by now. If any doubts, keep on like sending chats in the chat box and we'll keep on solving them as and when we go forward. So before moving to the services, what I would like to tell you all about is the different types of cloud. So now for the different types of cloud, we have four types of cloud. The first one is public cloud. Then we have private cloud. Then we have hybrid cloud. And the fourth one, which is multi-cloud. So what happens in public cloud is that there are third party providers. What are party providers? So like cloud providers like AWS, Google, Microsoft, all these are third party providers. That is, they are providing resources for me, which is the third party. For example, if I have my own company, now if I have to access the resources of Google, Amazon, or Microsoft. So they are the third party providers, and I am the first party. So what happens is that is when you call it as public cloud, as they are making it public for people or consumers. So that is what is called as public cloud. Now, what is private cloud? As I mentioned, if I have my own company, I'll build up my own data center. And with from that data center, I'll access the resources. So that is what is public cloud. That is the entire data center is only reserved for my own company or for my use. So that is called as public cloud. Now the next one is hybrid cloud. What hybrid cloud does is in hybrid cloud, you have mixture of characteristics of public cloud and private cloud. So what happens is if I have a company and I have my own data center. But now I want some more resources, but I don't want to get the hardware on my side. I just want to use it from some other provider. So what I can do is half of my data or is in my data center and some of the data which is in the other cloud data centers like Google Cloud Data Center or Microsoft Cloud Data Center. So this is what hybrid cloud does. Now there are also chances that some resources are also shared among the private and public cloud data center for a hybrid cloud provider. Now the next one is the last one, which is multi-cloud. Now, what multi-cloud does is, I am a user, and for a certain project or certain task, I'm using multiple clouds. That is, I'm working on Google Cloud as well, and I'm working on Azure or AWS as well. So I'm using multiple clouds for my usage and my purpose of completing my task. So that is what is called as multi-cloud. So these are the four types of cloud: public, private, hybrid, and multi. I hope it is clear by now. Any doubts? Hybrid. Okay. So first, I'm sending the names of the four types. So what is hybrid? So hybrid has features of both private cloud and public cloud. So if I am the user or I have a company, so I am using a, my own data center as well as I'm using the third party cloud. So for example, if in my company I own a data center. What is data center? Data center is a pool of like a network of servers or resources and so on. So I have my own data center, but there are certain task that I want to perform on some other cloud provider, that is Google Cloud or on Azure or on AWS, whatever the cloud provider is. So I want to perform certain tasks on their platform and on their resources which are available to us. So for that purpose, now what happens is I have my own data center which I'm already using, and now I have access to another cloud platform for doing certain other tasks. So that is what hybrid cloud means, that you are using the public cloud as well as you have your own private cloud. So that is known as the hybrid cloud. I hope it is clear now. Okay, moving forward. Now, all these clouds provide certain kind of services, and these services are categorized in three to four different parts. So, the first part is infrastructure as service. So, what is infrastructure? Responsibilities comes to the user. So that user has to do most of the work who is using the cloud platform. So what comes under infrastructure as service is you are deciding what kind of CPU you are using, what is the memory, what is the storage, all the networking thing, all the security and everything is handled by your side. You are also deciding what the OS are, what applications needs to be run, and so on. So that is called as infrastructure as a service. That is, most of the things are done by the user, which is using the cloud platform. Okay. So now some of the examples of infrastructure as service is virtual machines. So what in virtual machines, when you create a virtual machine, you are hosting an OS on some other OS which you already have. So that is called as virtual machine, where in between there comes something called as hypervisor and so on. So when you create virtual machines on cloud platform, that means that you are using infrastructure as a service. So that is one of the examples. Now, next we move on to is platform as a service. Now, what happens in platform as a service is you are given an environment where you can work and you only need to focus on the application that you're going to be building or running, the codes that you're going to be using, and so on. So, in infrastructure as a service, what you do is you have to handle all the resource creation, memory, storage, everything. But on platform as a service, an environment is already prepared. All the tasks which you are doing in infrastructure as a service is done in the background by the cloud provider. You only have to focus on creating your own application or whatever service that you are using. That is called as platform as a service. Now, some examples are when you go to Cloud Console or the cloud platform, you can see that there are certain IDEs which are also given to you to build your applications within the cloud. So these can be Eclipse, VS Code, and so on. So these are the examples of platform as a service. Now we go to software as a service. What is software as a service? Now here what happens is the software is already created. What you need to do is you can use the software. You can like uh, store your data or like use your data, supply your data. So all that you have to do is regarding your data. The application or the software or the service is already created for you. Now it is not like in like PAAS and SAS, you have to do like certain things are not being done. They are being done at the back end, but it is done by the cloud provider. You have to only focus on the data that you are providing and the data that you are using. That is what is software as a service. Now there is another which is a fourth kind of the service, which is not included in the slide, but is there in the ahead slides, which is called as serverless uh, computing. So what happens in serverless is what you are doing is you are creating certain functions like the example of serverless is cloud functions, and in that what happens is you have to only build the logic of using your resources or the functions that you want to perform. So you need not do anything like regarding the platform or the memory, storage, servers, VMs. You don't need to focus on anything. What you are doing is you are just building a logic that helps you complete your task in cloud. So that is what is called as serverless. So these are the four types: infrastructure as a service, platform as a service, and software as a service. And the fourth one, which I stated, is serverless. I hope it is clear. Any doubts? You can also like switch on your mics and ask your doubts if any. Okay, so I'm assuming that all your doubts are cleared. Moving on to the next one. So now we are moving on to Google Cloud. So the ones in the blue dots, as you can see, are the locations where the data center of Google Cloud is located. Similarly, other cloud platforms like AWS, Azure, they have their own data centers at various different locations. Now this map shows the data center of Google Cloud at various different locations on the earth, and the blue lines show the network between these data centers. Now, these are some of the resources that are provided by Google Cloud, and they include Compute Engine, Google Kubernetes Engine, App Engine, Cloud Functions, and Cloud Run. Now, we'll learn about these in detail ahead, but for now, I'm just listing out the resources that are present and offered by Google Cloud. So these are some of them which are under the compute resources of the Google Cloud. So these all come under the compute resources of Google Cloud. Next one is storage. So under storage, Google Cloud offers is Cloud Bigtable, Cloud Storage, then Cloud SQL. There's something called as Cloud Spanner and Data Store. So these come under storage device, like storage services. Then we also have big data, machine learning services and resources like BigQuery. We have Vision API, AI platforms. Then we have PubSub. Then we have Dataflow, Dataproc. Then we have AI platform notebooks. We have speech to text APIs. Then we have cloud transition APIs. and we have auto ML as well. So when you start learning all these from your learning paths, you will get to know more about in detail regarding each one of the resources. I will also explain it in the further slides, but these are the resources that Google Cloud offers. Now let's start with the platforms where we can access the Google Cloud. So there are four ways how you can access the Google Cloud. First is the Google Cloud Console. So Google Cloud Console looks like this. So this is the home page where you have this a Google Cloud account, and you can see this console. So basically, what Google Cloud Console is, it is a web user interface through which you can access the resources and work regarding your projects. The next one is Cloud SDK and Cloud Shell. So basically, the this is the command line interface that we use. If you are using it you are downloading the Cloud SDK and you are using it on your own device, that is the laptop that we are working on, then that is known as Cloud SDK. Then there is something called as Cloud Shell, which is already present in the Cloud Console, where you need not download anything and there is no such installation process. So that is known as Cloud Shell, and that offers certain amount of space and storage and so on. So this is all regarding Cloud SDK and Cloud Shell. Then next, we can also access the Google Cloud using REST-based API. That is, from our custom applications, we can access the Google Cloud using the APIs. The next one is Cloud Console mobile app. Very few of us know that cloud is also available on mobile apps, but Google also has its own Cloud Console mobile app, which allows us to use cloud from mobile phones like iOS and Android. So these are the four ways in which we can access the Google Cloud. The first one is through console, that is the Google Cloud Console. The next one is Cloud SDK and Cloud Shell, which is the command line interfaces. Next, we have through APIs, and next we have through the mobile app, which is there. I hope the four ways are clear. Now, y'all during the process are going to be using like some of these ways to interact with Google Cloud. And the first one which comes to you is the Google Cloud Console. So that I showed you how the Google Cloud Console basically looks like. So now what is Cloud Console? So it is the web-based GUI as I mentioned, and you can manage your projects, resources, and everything using this GUI. Then every cloud provider has its own console, and what you see on the screen is the Google Cloud Console. Using this console, you can create your resources, create your projects, manage your resources, assure the security and the health of your resources, and so on. Now, this is how it looks like. How you log into the Cloud Console is if you have uh, you require a Visa card if you have an account. So you might be knowing that you have to create an account on Google Cloud platform, and then you can access the resources. And as in when you access the resources, you are charged for that. But for this course, you need not do anything as such because you all are provided with the labs and the credits, you are provided with the account details with which you are going to perform all the tasks. So you need not create anything as such in actual. Now, how do we interact with the Cloud Console? There's this navigation pane on the left side, which consists of various different like resources, as I showed in the previous slide, the different resources which are present. Now, if you want some resources which you are frequently using and you don't want to scroll so much on navigation pane, you can also pin the resources so that it is available to you as in when you uh, open the navigation pane. For example, here you can see that this Kubernetes engine is pinned, and hence you can see it at the very first as well. Similar for cloud functions, but then for other resources, you have to scroll down and check what they are, and you can also pin them on the frequent ones. So that was all regarding the Google Cloud Console. Then what you can do with the projects is using the Google Cloud. You can first thing you can do is enable services and APIs. That is, you can use the Google services and you can access the Google Cloud using APIs. Next is enable billing. That is whatever you use, you have to pay for that. So that and for that to use, you need an account. So that is called as the your subscription or your billing and so on. Next is you can manage the permissions, credentials. If there is an organization and they have given multiple accounts to users, so they have to manage all the permissions that each user has and their credentials. For example, now when you have got your monthly subscriptions, you are coming under an organization or a team, and you are given certain access to certain resources only. So those are your permissions and your credentials. Next, you can also track the resource and your usages. That is, you can know how much you've used a certain resource and how much quota you have for that resource which is remaining. So all that you can see while using the cloud. Next, you have is programmatically manage your projects in Google Cloud. So all the projects that you are doing on your device or on-prem, you can do that on the Google Cloud as well. So I hope this is clear. These are some of the features that you can access using Google Cloud. Moving on, when you are using Google Cloud, there is one main entity which comes, that is known as project. So under the what project is, it is the combination of all the resources that you are using. So that creates one project. So if I am creating a project, the three main attributes that I have is the project ID, the project name, and the project number. Now, as you can see the features of all these, project name is unique and it is chosen by you. And you can also use the same project names like it is not unique, and you can use your own project's name as and when you want. So that is the project name. You can choose your own project name, or it will be assigned on the with default, and you can change it during the creation. Okay, so that is regarding the project name. Now, when you create your project name, you have a project number which is assigned to your project, and a project ID that you are creating during the creation. So what you can see during the creation is only two terms, that is project ID and project name. But once the project is created, you get to see the third attribute, which is the project number. So what project ID is, it is a global unique ID which is given to your project, and that ID is not same with any other projects. Now, when you create, it is assigned by the Google Cloud. But if you want to change that project ID, you can also give your own project ID. But once you have created the project, you cannot change the project ID. But while you are creating the project, you can change the project ID. So I hope that is clear regarding the project ID thing. Now, what project number is, it is unique again, and it is assigned by Google Cloud once the project is created. Now, these two terms were during the project creation. Once the project is created, you get your project number. That is globally unique. It is assigned by Google Cloud, and you cannot change that project number. So I hope it is clear for you all. Any doubts? Which last one can you specify like clearly? Shashank, can you please repeat your question and clarify what you want to know? Okay, serverless. So what serverless does is, for example, I'm taking, just giving an example. I'm creating a project and I want to know a vehicle's time space when it is and when the uh, picture is captured. I want to know what the vehicle number is. That is the MH numbers that we have on the vehicle. So I want to know the license plate number. I want to know when the time space and when the picture was captured from the IoT device. So now for that, what resources I require is, if I want to know a license plate number, first thing is I want to store that IoT captured image in my storage account. After storing that, I want to, as soon as I store the image, I will use certain resources like computer vision, custom vision, and so on, and I can get to know what the license plate number in that image is. For example, now you also have option on the Google search engine where you can scan certain pictures and get to see the or copy the text. So similarly, custom vision does the same. Extracts text from the images. So now, since the text is extracted, I want to store that in a database. So I want to store all the car details in a database. So these are the three resources that I use. One is for storing the image. The other is for getting the uh, getting the text, and the last one is to storing the all the car details. And one more, that is to capture to linking it with the IoT devices. So for doing this project, I required four resources. Now, if I want to connect these resources, I might need to perform certain tasks. But I don't want to do that hectic tasks, and I want the Google Cloud to manage it on its own and do all the process. So now, in that case, what do is I use certain functions. Now, what that function does is, according to an event, it triggers the function and it automatically runs all the required tasks. So now I can give it like, if I get an image in the storage account, what I have to do is I have to activate the custom vision, and then I have to store the details in the database. So this entire process is done automatically when I create the function. So I need not do anything and anything use on the cloud. Whenever the image is uploaded, it is already doing the all the tasks. So there is no involvement of me except the creation that I did. So once I've created everything, I need not do anything. Everything is handled by the cloud. Also, I'm using no codes. So I'm not coding, I'm not using any languages, I'm not using any IDEs. So that is called as serverless. What serverless does is, there is least involvement of the user, and you can make cloud do things for you automatically. I hope that is clear for now. Yes, exactly. So I hope it is serverless is cleared, and project ID, project name, and project number is also cleared. So these are the three attributes, and the project is the main entity which is there. Next, how do you create a project? There's a project, like here you can see all the project in which you are now. And to create a project, you can click on this and create a certain project. And then when once the creation is done, you can see this search project infos under your account. So whatever project is there here, you can see the infos and details on the home account. So I can also click on this arrow and switch between certain projects. So this is how we create and switch between projects. Now to create a project, you can click on new project, and this is the example of how you create a project. So here I have given like certain in the image we have given the project name, and obviously you have to mention the account which we are using to create the resources or the project. And once you enter the project name and this, you can see that a project ID is automatically created below the project name here. So, so if you want to edit this, you can use the edit option to edit this project ID, or let it be the same as Google has advised. But once it is created, you cannot change the project ID. So this is project name, this is project ID, and you can edit both of them during the creation. Okay. Now, once the project is created, you can see that a project number is generated, which is this over here. So these are the three important information regarding a project: the name, the ID, and the number. Now, how billing works. So, as I said, you only have to pay for projects and resources that you are using. So that is the first point. If your account is linked to zero or more projects, there you like your one single account can be related to multiple projects. So that is the second point. The third is you can like automatically, as and when you use the resources, you are charged and certain amount is reduced from your account. If you want to limit your usage, then you can set a threshold limit. So once you reach a certain limit, they can set an alarm and show you that you have exceeded the limit, and then you can stop certain using certain resources. Then you can also have sub accounts for different billing for like different projects. So the second point was that you can have one account for multiple projects. The another one is you can have different accounts for different projects. So that is what it states. I hope it is clear. Now talking about now all these were about the Google Cloud Console. Now we move on to the Cloud SDK. So as I said that it is a command line interface. So basically you have to work on the Cloud Shell or the Cloud SDK to access the resources. So the main three keywords or services that we use is like it is the G Cloud, the GS Util, and BQ. So G Cloud is for the overall resources that we are going to use, and GS util is basically the Google storage utilization that or utility that we are using. And BQ is for big queries and so on. So these are the three main words that we use while using the command line interface. I hope it is clear. So, moving on to Cloud Shell. So, basically, Cloud Shell is alternative of Cloud SDK. What Cloud SDK is, you are downloading the Cloud terminal or the SDK on your device, and you are accessing the cloud resources. But what Cloud Shell is already available on the Google Cloud platform or the Cloud Console that we say in general. So, it is already available on the Google Cloud, and you can directly access it from the cloud console. So you need not download anything for accessing the cloud. So that is what Google Cloud Shell is. So it is a browser based CLI. CLI is command line interface, and you can access the resources through the cloud shell. Then you need, as I said, you need not install the cloud SDK or any other tool. Then you are running the cloud shell or at no cost, so it is not costing you anything to run the cloud shell. The default storage for the cloud shell, which is provided by Google Cloud, is 5 GB for persistent disk storage. And you can have a web preview of whatever you are doing in the cloud shell as well. So there is an option of web preview there which you can access. So this is the cloud shell option on the Google Cloud platform. Once you click this button, you can see the cloud shell, something like this on your console. Now on the left, if you see, there are certain options that are available. So from which the option like this is the editor. So from the Cloud Shell, you can directly open an editor which has similar features like VS Code. So you, instead of using the Cloud Shell to build the project, you can also use the editor from here, where you can create your different files and all. It is similar to the how VS Code works. And then we have something called as web preview. whatever you are doing, you can see the web preview when you click on the option or the button on the left side. So this is basically close, maximize, minimize, editor, and preview. Now, when you click on the editor, you can see, as I said, this is the IDE which is available, and you can access this Cloud Shell code editor. And there are certain like folders and all that you can create and write your codes and everything here. You can also write this commands here for the Google Cloud Shell. Then we move on to the mobile app that I mentioned. Many few of us know about the Google Cloud mobile app that is available. So that provides some kind of similar kind of services that is provided by the Google console, and you can create instances, you can check how the billings, and you have the various permissions monitoring. You can see your resources, how much if they are on, if they are off, and so on. You also have access to Google Cloud Shell when you open the Cloud Shell. So this is what a basically Android or OS device has, like a mobile app, which is there. So now this was all regarding how we can access the Google Cloud, about regarding projects, and for like till now we have discussed various types of clouds, various types of services, various types of resources that are present, and we have discussed about how we can access the Google Cloud. I hope it is clear. Any doubts? Okay, moving on to the Google Cloud Compute Services. So under the Google Cloud Compute Services, as I showed, there are different resources, that is Compute Engine, App Engine, Cloud Functions, and Google Kubernetes Engine. So what Compute Engine does is you have like virtual machines that are created, and for that virtual machines, you assign certain storage and other such features to that virtual machine. You decide what OS the virtual machine will have, and so on. So that comes all under Compute Engine, and it is an example of infrastructure as a service, as I mentioned. Similarly, we have App Engine, which is a platform as a service example. And here you have a platform. This is a platform which is available for y'all to build your own applications. So that is known as App Engine. Then we have Cloud Functions, as I mentioned, they are serverless logic. And using Cloud Functions, you can you can like activate certain actions without coding or without doing anything else. And that is what is serverless logic. Now I'm repeating it again. Serverless doesn't mean that things are not happening. They are happening at the background and they are done by the cloud provider. What you are doing is you are just creating and connecting all your services. You are not coding, but you are connecting the resources and services that you are using. Next we have is Google Kubernetes Engine. So what Google Kubernetes Engine does is, here comes a main feature that is known as container. So I will explain about containers in detail as and when we go ahead. But what Kubernetes does is it handles the different containers that are given to the engine, and it handles various features like load balancing and monitoring the health of the container and so on. So that is called as Kubernetes engine, and it is an example of hybrid type of the service, or like you can say it is the example of hybrid type. So I hope it is clear regarding compute services. Now we will be seeing each one in detail ahead. So like compute engine, app engine, cloud functions, and Kubernetes engine. Let's go in depth about each topic. What is compute engine? So it basically creates and runs virtual machines on your Google Cloud infrastructure. And using, like, to get access to these, you have your pricing models and the consumptions and all the limits that you've set. You can use it according to that. So basically, compute engine deals with all the creation and running of virtual machines and so on. Now, serverless, as I said, that in serverless, you are not doing anything. Everything, like in gray, is done by the cloud provider. That is in our case, it is Google for now. And the two things, that is application development and performance monitoring, it is managed by the customer. So now your application development and performance monitoring doesn't mean that we are coding or we are doing performing certain building operations, but here what it means is we are just connecting the various resources that we are using. So that is what we called as application development. And for performance monitoring, you are just checking how the functions are working and so on, as and when you need, or depends on your requirements. That is what serverless compute is. Now, these are some of the features of serverless compute. First is that you can deploy and scale your applications fast, and they are secure as well, as Google is managing all the security process. Now, using this serverless compute, you have a fully managed environment, and you just have to like wait for your outputs and so on. So it does auto scaling. So as and when the demand increases, it can scale your resources to a certain extent. Then you don't need to manage any infrastructure here, and it like speeds your output, which can speed your like effectiveness of the project. So that is what serverless compute is. Now, as we are mentioning scaling over here, let me introduce you to what scaling is, and what are the different types of scaling. So here, in this image, as you can see, there are two types of scaling, that is vertical scaling and horizontal scaling. So on vertical scaling, what you're doing is, if I have like created a virtual machine, and the storage of the virtual machine that I assigned, as I said, was like 15 GB, suppose. So now the demands increase, and I want my like for the application that I'm using, my application demand increases, and now I want certain like storage accounts, or certain storage which is higher than 15 GB. So suppose I purchase 30 GB of storage now for the same VM that I had created, and that helps me to manage the situation of my application needs. But now what happens is, as the user, like, now the user was one, so this was the storage. Then, as you can see, the user increases and the resources increase that I'm using. But if again, when you go back and the peak time is off, so now the users will decrease. So then you have to, like, then there's like most of the storage that you had purchased is unused now in that case, and you cannot go back to the previous situation. That is, for example, suppose we are considering our college website. Now, during the times of admissions, or while filling the admission forms and everything, we know that there'll be a high demand and high access of the like web application during that admission time. So basically, if I have increased the resources during that time, but now since the admissions are done, very few people are accessing the website. But now I cannot go back to the previous situation where I had less storage, or less use of resources. So that is what we called as vertical scaling, that once purchased, you cannot go back to the previous thing, because you have already purchased that amount of resources. So that in certain situations becomes a waste of resources. I won't say that you should not prefer vertical scaling, but it depends on the situation which you are dealing with. Obviously, you can you can prefer vertical scaling for some fixed tasks that might require that amount of resources. But in the same scenario, if I consider, now I had created one VM here, which was able to handle suppose 100 people. Now, as my demand increases, so now there are suppose 300 people. So for them, as and when my demands increase, I have created another VM, which is the copy of this VM. Now here what happening was is in the same VM I am adding the resources. Here what happening is I am creating the copy of the original VM. So here as and when the demand increases, the copy of the VMs is increased, and the entire traffic is managed between the VMs that are present. Now, when the peak time is over and we again have less users, then these VMs can be stopped and we will not use these VMs, and they are accessed for some other purpose. So now when the peak time is over, now what you are doing is you are again using the original VM that you had created, and you are not using anything else. So this is how you save the resources in this situation. There might be situations where vertical scaling is beneficial, and there might be situations where horizontal scaling is beneficial. But I hope that the basic concept of scaling is clear for you all. Any doubts? So here we are increasing the hardware capacity, and in the second one we are increasing the we are making copy of certain resources and we are using it. And once the use is done and we are reaching back to the original position, it goes back to the single VM that we had previously created. I hope it is clear now. Okay, let me explain it again. So here, what is happening is, for example, if I consider my Google Drive. So for my Google Drive, if I suppose I have 15 GB storage, and now my storage is full, and for the same account, I have I want like more storage. So there's option where you can purchase more storage by paying or whatever the process is. But now here what you are doing is, as your storage was over, you are purchasing more storage. But after purchasing that storage, you are increasing the storage capacity of your account. So that is known as vertical scaling. Also, once the storage is purchased, for example, you cannot go back to having 15 GB now since you have 30 GB. So that is what basically vertical scaling is all about. But in horizontal scaling, now if I have a Google account and a Google Drive account, and it has my storage is full. So what I can do is I have an alternate Gmail account which I'm using for the storage purpose of my resources or the photos and so on. So that is what is horizontal scaling. I hope it is clear for now. So here you are increasing the hardware capacity of the same resources, and here what you are doing is you are duplicating the resources and using it. I hope it is clear for now. Yes. Moving on to our slide. So that was all regarding scaling and serverless compute. Now, these are some examples of serverless compute, and these three are App Engine, Cloud Run, and Cloud Functions. So what App Engine does is it is regarding the web applications, and Cloud Run is regarding the containers, and Cloud Functions is event driven. That is, it triggers when certain event is done or certain actions are done. So these are the three examples of serverless compute in Google Cloud. Now, as I already mentioned, what App Engine is, it is a type of public platform as a service that is known as PaaS. and you need not build or operate or any you don't need to handle any hardware or infrastructure requirements. You are just like using the you are just focusing on the application that is there. Then you are not managing any servers, you are not deploying anything. As I said, you are only focusing on your app development operations. You can use various languages, various tools. You can also auto scale your process. So that is what App Engine does. So it is an example of PaaS, that is platform as a service, in the service thing. The next we go on to is Cloud Functions. As I explained that it is an event trigger. So what you need to do is you need to decide the resources that you are going to use. Then you have to create an event which when triggered will do perform all the serverless tasks. So that is what Cloud Function does. Moving on to containers. Containers are basically packages of softwares that you are using that are necessary to run your application or any other experiments. So in containers, you can store any kind of language files or any libraries, images, and so on. So basically, for doing a certain task or a certain project, all that is required from dependencies to packages and so on, everything is included in one container. That is what container is. Now, what Cloud Run is, Cloud Run basically manages the containers that are there, and it fully manages the entire environment. You just need to hand over your container to Cloud Run. So basically, if you want to deal with containers, the easiest way to do it is using Cloud Run. Going more in depth with the containers. So containers, as I said, they are packages and softwares and dependencies that you are using to build a single like project or application and so on. Now these images that you see are the data centers. Now what happened, why we are using container is many a times people think that VMs and containers are similar, but they are not. What VM is, you are creating the entire virtual machine. That is, it is hardware specific. You are creating the entire machine where you have OS, you have storage, and you have your applications running on that, and so on. That is VM. But what container is, it is OS specific. That is, you decide that is, you have all the things related to your application project and so on. So, VM, you can basically think that you have a device. In the device, you are creating another device which has different features than your original device. So, that is VM. But what container is that you are creating, it is the OS specific. So you are creating a certain projects, and regarding the project, everything that is required is under one container. Now, why we use container in most of the situations, and why nowadays it is containerized, like you hear the word containerization nowadays a lot. So why containers are preferred, because in VM you are like using the resources of the entire what what the machine entirely requires. So that utilizes most of the resources from the data center, which some of which we are not even using. So there it leads to like wastage of certain resources. But what containers do is they only have the resources and the packages and everything that is required for the working of your application, and you can run it in any environment, even on your device, on prem or on the cloud. So it is a complete package of a single project or a single application. So that is called as container. And the container only uses the resources which are which are for the application purpose. So the containers can be assigned to any data center and any server which is flexible to use. So that is why we use containers. Coming out to Kubernetes, as I said, that Kubernetes handles the related to container. The basic you can start with is Cloud Run, which handles which does the same task and some more task like Kubernetes, but that is done by the cloud provider. It is not like Cloud Run. Nothing is happening at the background. Everything is happening at the background, but it is done by the cloud provider. What you are doing is just using your container. But what Kubernetes does is, in Kubernetes, you have to handle everything related to your container. That is, you have to schedule your processes, you have to check the life cycle, the health. The scaling is also done by you. You have to balance the traffic, and you have to decide how much storage you want, and you have to keep on monitoring your container. So that is what Kubernetes does. So it is basically starting from the scratch regarding container and doing everything which is supposed to keep your container efficient and easy to use. So, but that assigns most of the task for the user. But what Cloud Run does is it does similar tasks to Kubernetes, but that is done by the cloud provider. I hope it is clear by now. So for now, these are the topics that we are doing as we are running out of time. I would like stop here and take all the doubts that you all have. Any doubts you all can ask. Okay, so I hope the concepts which I explained are clear. Will like proceed with the further information in the next meeting. Now, before I end the call, I would also like to show the process of how you can continue your labs. And the requirement on your side is that you complete at least one module a day and try to finish 4 modules in this week, uh, as um, as it will be easy for y'all since this week there's not much going on, but in the further weeks there might be eyes for certain people. So that will cause you all to stop focusing on this section. So it is advised that in the coming week you complete 4 modules that are the basic and necessary modules, so that you are at least done with half of the process, and there is only Gen AI and the other 4 modules to complete. So if you complete it on timely basis, it might be helpful for you all to manage your time and to handle the other college related tasks as well. Regarding the learning parts, it is not that difficult. You all have videos that are there for you all to explain the concepts. I've already explained some of the concepts here, but in you will also get to know more about those in the videos that you all watch. After watching the video, you all will have labs and quizzes. Even the labs, it is just what you need to do is follow the requirements and steps that are mentioned, and that will be easy for you all to complete the lab then. It's not what you need to do is just follow each and every instructions carefully and go on in the same manner as it is given, like module 1, module 2, module 3, module 4. Now, why I am saying module 4? Because when you complete these 4 modules, these were the main modules, and the rest of the modules are are somewhat related to the further 4 modules. Module 1 might be related to module 8, and so on. So certain interrelations are there between the modules, but that is why I'm telling you all to go in a certain manner and complete the 4 modules first, and then we'll focus on the next 4 in the next week. So that is what the task is, to complete 4 modules in this week of GCCF. Obviously, if you all have time and if you all want to do more, please proceed with the other modules. Now, I want to know from your side that you want me to complete the labs and send a recording, or you all can follow the procedures and do it on your own, and so on. So what is the requirement that you want to complete your labs? Do you want my help, or would you like to try it on your own first, and then if any doubts you will reach out to me? Okay, so as you all said that you all are going to try it on your own, so please try it on your own. And if any doubts, you can message me personally or on the group. And if needed and you are facing certain difficulties in certain labs, I can also provide the video recordings for the same. So that is what I had to say. The next thing is I'll just go to my account and show y'all how to uh, proceed with the labs and what y'all can see on your profile. So as you go, you have this enrollment email. If you want to quickly access the modules, you can just click on this link and you will come to this page. Now here you can see this progress bar which shows how many, like how much I have completed the learning path. And then when you start completing the parts, you can see you get certain points and certain uh, recognition on this side. So as and when you go through the labs, this bar will keep on completing. And once it reaches this 170, it means that you have completed the entire part and you can get your badges. Furthermore, if you want to start your learning path or you want to continue it, just click on continue learning or start learning, which is there over here. Or you can click on learn more on the specific module. So this is how you can access the modules. Clicking on the first module, and when I click on learn more, you will get to see certain sections and videos in that. There'll be certain quiz, lab, and so on. So as you see, once you complete certain video or anything, you can see a tick mark over here. Now, when you see that these are the sections which are there, some are introduction videos, some are quizzes, some is the summary video, and so on. So you have to go line by line here, keep on going, and keep on watching the videos. Now, furthermore, when you go, you will see labs which have certain symbols like this. You have to go there, and on when you go there, you have this option as start lab. So when you start the lab, you have to go by the procedures that are mentioned here. So as how it is mentioned, you have to go according to that, and you can access and like you can complete your lab. Now, once you complete your lab, you can see that this dash increases to 100 by 100. That is, you have completed your lab, and now you can end the lab. So once this reaches 100, there is also a process where you can track how much you have completed. So once you go, you have to click on something so at the end when you go, you will see a button like check my progress. So once you have completed the further steps, you will see that this button is there. You can click on that, and once you get a tick mark over here, that means that you have completed the lab. Then complete all the MCQs which are there, and you can end the lab. So basically, what you have to do is you have to follow the procedures that are given in the lab description itself. Now, how to access your Google Cloud account? You need not create anything on your own. I have sent the recording of already on the group. Once you start the lab, you can get to see something like this on your left side. So this is the Google account which is newly given to you to do your lab. So you do not need to use your account or any other account. You have to use these credentials which are mentioned here. So once you enter the username and password which is provided here, you can see that it is the you can start accessing the Google Cloud Console. Now, once you can access the Google Cloud Console, you can proceed with the main parts. That is, for example, this is the task 2. Similarly, you have task 1, which is there mentioned above. That is accessing the Cloud Console. So these are the certain tasks which are given and you have to complete. I hope it is clear. Any doubts? Okay, so we will be ending our meet here and won't take up much of your time. I've already exceeded 15 minutes. So the recording for those who have not attended will be sent on the group soon. I will also share some learning materials for you all to know more about cloud in detail. Also, you have access to internet. You can also search your doubts on Google and YouTube, but I will provide some links from where you can know more about cloud. So I hope everything is clear. Any more doubts, you can contact on the group or contact me personally. I'm ending the meet now. Before ending the meet, I would also like to say that it depends on your performance of in which tier we belong. So if most of you all complete your task,